Let's solve for this system of three equations. We're going to find all three variables x, y, and z in 4 steps. So I have those 4 steps written here. First, we're going to solve for one of the variables from any of the equations we want to pick. Substitute that specific variable's expression or value back into the other two equations. Solve for the next variable, sort of repeat this process, plug back in to solve for the other two missing values. I'll have that on the side. And we'll begin by picking one of these equations. How do you know which from the three equations to pick? I'm going to go with this one because it seems easiest to solve for one variable by simply adding a 2y to both sides. So that becomes x equals 5 plus 2y. Okay, step 1 complete. Now step 2, I'm going to go ahead and insert that x expression for x into both of these other two equations. So 3x becomes 3 times 5 plus 2y plus 4z equals 11, negative 11. And go ahead and distribute to keep solving here. We have 6y. And you can bring that 15 over to the other side. That we have 6y plus 4z equals negative 26. Okay, so that was the first equation. The next equation we need to plug into is this one here. I'll use another color, green. 4y minus z equals negative 10. Now that did not have an x present in it, so we actually don't even have to plug anything into it. We could simply combine these two together and use substitution or just simply add them together and eliminate the process of elimination. And I'm going to move this over so that they're side by side. And yeah, I think the method I want to use here is now an elimination. So I have the 6y plus 4z equals negative 26 and 4y minus z equals negative 10 on bottom. So I can make these cancel if I multiply the second function by a positive 4. Okay, so altogether I'll have 6y plus 4z on the top did not change. We didn't multiply it by anything, so it stays the same. But the bottom function becomes 16y minus 4z, and that's equal to negative 40. Now we can add these up. You'll see that these go away, whereas the 6 and 16y becomes a 22y, and negative 26 minus 40 becomes negative 66. It becomes a single linear equation that we can solve by dividing out the 22, and we should end up with negative 3 for y. So we have one of our variables solved for. So we've already completed 2 steps. We're going to do this last step, plug that y equals negative 3 value in for the other equations from the system originally. And that way we should have our x and z variables be solved for and sort of fall into place. So y equals negative 3, I'm going to go back up to the top. And I can see there's y present here and here. So we'll go ahead and write x minus 2y equals 5. And substitute, remember y was equal to negative 3. That becomes x minus 2 times negative 3. And using the rules of equality, we end up with our second variable being solved. X is equal to negative 1. Great. If we want to solve for z, that's going to be this last equation we can plug in. By the way, if you plug these values into any of these 3 equations, they should all check out and equal the same thing. So you can pick whichever equation that you want to plug in. I have 4y minus z equals negative 10. Again, y was equal to negative 3, which we solved for. So I got 4 times negative 3 minus z becomes negative 12. And if we add 12 to both sides, I have negative z equals positive 2. You can switch the negative over to the other side by dividing or multiplying by negative 1, and you end up with all three variable values solved for. If you'd like you can write it all as a three-dimensional point where x comes first, y then z, negative 1, comma, negative 3, comma, negative 2. And that's how we solve a system of three equations.